We did it. No more fossil fuels, no more carbon. Fusion saved us. Well, until the planet froze. Because when we, primates with a history of catastrophic ideas like coal, oil, nuclear arms, are handed limitless energy, we don't just switch on the lights. We tinker, we push, and inevitably, we trigger forces we barely understand. But how close are we to actually harnessing fusion energy? If fossil fuels disappear, will the planet finally cool down? Or are we in for another surprise? If we control the thermostat, who decides what's just right? What happens when climate hacks go wrong? Very, very wrong. And the main question no one wanted to hear. What if all this clean energy ends with frostbite? Fusion, humanity's ultimate power-up, no carbon, no smoke, just endless clean energy. Finally, we can beat climate change. In Massachusetts, the SPARC reactor developed by Commonwealth Fusion Systems is on track to demonstrate net energy gain by 2025, aiming for commercial fusion power within the decade. Meanwhile, in France, the ITER project, a collaboration of 35 nations, has recently received its central solenoid, the world's most powerful magnet, marking a significant milestone towards achieving 500 megawatts of fusion power from just 50 megawatts of input. Across the globe, China's East reactor, dubbed the artificial sun, set a new record by maintaining plasma at 108 million degrees Celsius for over 17 minutes, bringing us closer to sustained fusion reactions. Also in France, the West tokamak achieved a breakthrough by sustaining ultra-hot plasma for 22 minutes, a critical step towards continuous fusion power generation. But here's the thing about energy. It doesn't vanish. Every light bulb, every smartphone, every electric car, every data center, all of it eventually becomes heat. Today, this waste heat barely registers. Globally, humanity's energy use adds about 0.03 watts per square meter to Earth's surface. Nothing compared to the 3 watts per square meter from greenhouse gases like CO2. But fusion changes the game. Experts project that if global energy demand rises to 500 to 1,000 terawatts, plausible in a fusion-powered future, waste heat could reach 1 to 4 watts per square meter. That's not trivial anymore. That's enough to raise global temperatures by 1 to 3 degrees Celsius purely from our machines running endlessly. No carbon, no emissions, just heat. Silent, relentless, unavoidable. In fact, theoretical models warn that if humanity ever reaches so-called Type 1 civilization energy levels, about 4,800 terawatts, waste heat alone would drive more than 3 degrees of planetary warming, even in a carbon-free world. Energy in, heat out. It's not a flaw, it's physics. And no matter how advanced we become, that bill always comes due. So, if fusion promises endless power and waste heat threatens to quietly overheat our world, what happens when we decide to take matters into our own hands and force the planet to cool down? Would you dare take control of Earth's thermostat? Let us know. How cold is too cold? For most of history, the idea of hacking the planet's climate belonged in the realm of science fiction. Not because we lacked imagination, but because we lacked power. Inject aerosols into the stratosphere, brighten marine clouds, launch giant mirrors to block sunlight. All bold ideas, all impossibly expensive, when energy was scarce and dirty. But fusion energy rewrites the rules. Recent breakthroughs suggest fusion could deliver near limitless power at around $25 per megawatt hour, cheaper than coal, cheaper than wind. An energy cost low enough to make even the wildest geoengineering schemes financially and politically tempting. Consider stratospheric aerosol injection, the process of spraying fine particles into the upper atmosphere to reflect sunlight. At current estimates, it could cost as little as $2 to $10 billion per year to cool the planet by 1 degree Celsius. In a fusion-powered economy, that's spare change, the price of a single major infrastructure project. Even the more ambitious proposals, like orbiting sunshades, shift from impossible to plausible. But the cheaper it becomes to hack the climate, the greater the temptation to do it without permission. And here lies the real danger. Who decides when to pull the global thermostat? Today, there is no global treaty governing geoengineering, no international agency with authority to approve, delay, or stop a planetary-scale intervention. Which means, if a country or a corporation believes it's suffering from droughts, floods, or fires, they could decide to act alone. And once they start dimming the sun above their own skies, everyone else inherits the consequences because geoengineering won't cool the Earth evenly. It will redraw rainfall patterns, it will rewire seasons, it will decide quietly and invisibly who eats and who goes hungry. The first one to hack the planet may not be the wisest, the fairest, or the most careful, just the fastest. But what happens when the hacks can't be undone and the planet starts unraveling on its own terms? Every hack comes with risks, and geoengineering is no exception. Stratospheric aerosol injection can cool the planet, but if the planes stop flying, war, collapse, negligence, the shield falls. Within just 5 years, temperatures could spike by 1 to 3 degrees Celsius, unleashing what scientists call termination shock, a violent resurgence of heat. Oceans warm, ice collapses, weather systems fracture. But the opposite can happen too. Cheap fusion means almost endless power and endless ambition. So why stop at aerosols? Enter carbon dioxide removal, now scalable, now easy, now global. Fusion allows us to vacuum carbon from the sky at historic rates, down and down and down. But here's the danger. CO2 is not just pollution, it's Earth's thermostat. During the last ice age, CO2 dropped to 180 parts per million. Today it's over 420 parts per million. But what happens if we overshoot our correction? Less CO2 means less heat. Less heat means more snow. More snow means higher albedo. The planet reflects sunlight. The cooling feeds itself, glaciers creep, crops vanish, seasons die. Welcome to the feedback loop. Not of warming, but of freezing. And in this version, there's no easy fix. Once snow and ice expand, they increase sunlight reflection, and the planet locks itself into cold. At that point, even flooding the skies with fusion-powered heat may not be enough. Cooling weakens the ocean's great conveyors, the Atlantic meridional overturning circulation. Without heat moving north, winters deepen across Europe and North America. Snow, cold, silence. And in desperation, nations may not retreat. They may push back, harder, more aerosols, more hacks, more chaos. When every country becomes a climate engineer, the thermostat becomes a battlefield. One nation freezes for survival, another demands sun for crops, a third retaliates for drought. And so, humanity's final war may not be over land or oil, but over the temperature of sunlight itself. We conquered energy, we mastered the sun, and in doing so, we froze our only home, not by accident, not by disaster, but through our desire to fix everything, until nothing was left to fix. So if given limitless power, would you dare dim the sun? Would you pull carbon from the air and risk a world where spring never returns? But remember, once winter arrives, it may never leave. We always start with good intentions. When coal emerged in the 18th century, it was celebrated as a savior. The forests were being stripped bare, wood shortages threatened industry. Coal offered salvation, abundant, powerful, and modern. By 1900, coal powered everything, factories, ships, railways. And yet, by the mid-20th century, it coated cities in poisonous smog. London's Great Smog of 1952 killed over 12,000 people, not in war, but in peacetime, from simply breathing. And long before we coined the term climate change, coal's invisible legacy was already filling the sky with carbon. Next came oil, a golden liquid, easy to transport, cheap to burn. Oil transformed economies, cars roared to life, planes shrunk the world. But with it came wars, spills that choked oceans, and a century-long addiction. By the time scientists warned about greenhouse gases in the 1950s, the Keeling curve quietly rising at Mauna Loa, we were already hooked. Oil, the liberator, became the architect of planetary fever. Nuclear arrived as the clean alternative. No smog, no carbon, but splitting atoms gave us more than power. It gave us Hiroshima, Chernobyl, Fukushima. The age of nuclear fear began almost as soon as the age of nuclear power. By the 1980s, public trust collapsed. Nuclear plants sat half-built and abandoned, a technology of peace, forever shadowed by war and disaster. And now, fusion. The ultimate promise, endless energy, no emissions, the clean slate. But history whispers a warning. Every time we solved one problem, we created another. Coal ended deforestation, triggered smog and carbon overload. Oil fueled prosperity, triggered wars and climate chaos. Nuclear ended smog, brought extinction risks and radioactive legacies. Fusion, too, carries this seed. Abundant energy means abundant intervention. Cheap power means cheap experiments. And easy climate control means easy mistakes. The lesson of the past is clear. It's not that energy is bad, it's that we are reckless when we think we've mastered it. We don't know when to stop. We don't know how to share. And we certainly don't know all the consequences until it's too late. When fusion saves us from fire, it may yet deliver us to ice. And the cruelest irony? We did it not through malice, but through ambition, through our relentless desire to fix, through good intentions that, like always, paved a road to somewhere dark. So if you could hold the sun in your hands, would you still use it? Think carefully. History suggests we won't handle it wisely.